Okay, I'm going to try to do an overview of 6.6 scientific notation, just picking a few problems of different types. I'm not even going to try to be thorough with this because this is something that y'all should have been doing actually from about 6th grade on. It says problems 1 through 10 transform to scientific notation, so you've got the 372,000, okay? Now, if you remember in scientific notation, what you want to do is you want to go find, you've got to have a number between 1, you can't, a number between 1 and up to 9, including 9, to the left of your decimal place. So this is going to become 3.72. And then I'm going to tell somebody how far. I'm going to rewrite the number by multiplying it by a power of 10. I have to have all these digits that are not 0 in here so that, we get the whole number back. Now, the decimal point was here. I had moved it here. I have to move it 1, 2, 3, 4, 5 spaces to the right to get it back to where it's supposed to be. When you get done, you want to be able to scoot that decimal point however many places you've written up here in your exponent. And if it's positive, it goes to the right. If it's negative, a negative number there, that means you're moving the decimal to the left. Let's look at one where you'd have to move it to the left. Let's look at number 3. Okay, so you've got 0.00261. Now, I never liked these leading zeros because I think they confuse people. Now, what I want to do, remember, I'm going to have my decimal point still, but I need a number. I can't have 0 out there. But the first number that I come to that's not 0 is 2, and I have to have the 6 and the 1 there. Okay, now, if I want to make sure that I've got the same number, what I just did was I temporarily moved the decimal point here. It was really here. How many spaces do I need to scoot it if I want to tell somebody how to get it back to this original form? Well, they need to scoot it, since I put it here, they'd have to go 1, 2, 3 to the left to get it where it really goes, wouldn't they? So since I'm going to the left, it's negative, and since I scooted 3 spaces, it would be -3. Okay, let's look at some of these problems that you may not have. Not sure if you've done any of these before. Maybe, maybe not. I think it depends on what book you used. So you've got 2 times 10 to the 7th and 3 times 10 to the 8th. Now, one thing I'd like to kind of remind you about is that x, that multiply sign is an x. We haven't seen that in a while, have we? It's used in scientific notation, but couldn't you just as well have written this as 2 times 10 to the 7th times 3 times 10 to the 8th? When you see it that way, it may make sense to you that what I'm going to tell you to do is you multiply the whole number parts, the 2 and the 3 up here, because couldn't I just multiply this 2 and 3 and get 6? Because, the commutative property and the associative property says I can change the order of all these things I'm multiplying. Now think about, we've got 2 things with base 10. And when we multiply 10 to the 7th times 10 to the 8th, you've been doing that in this chapter. If you remember, when you multiply, the rule says we add the exponents, so 7 plus 8 would be 15. So this is 10 to the 15th. I could write it like that, or I could write it like they do here. Do you see that all you're doing is multiplying things, whole number parts together, and then since you've got in scientific notation, you have all these base 10s, you could just add the exponent on the 10s, and there you go. You've got your answer right there. That's 6 times 10 to the 15th. And I didn't turn on the... I've been talking away. Okay, I already worked this problem because I didn't realize I didn't turn the sound on. What I did was I said 7 times 5 is 35, and I wrote my 35 down. And then I said, okay, I've got 10 to the 4th times 10 to the 11th, and when I multiply with the same base, if you remember, we just add our exponents. So 4 plus 11 gave us this 15 here. Now, that's not proper scientific notation form, because in proper scientific notation, the decimal place, I'm drawing it in blue here, it has to be just one number to the left of that decimal place, and that number has to be 1, it can be 1 through 9, but it can't be 2 digits. So what I've had to do is in order to write it correctly, I've had to move it from where I had it back another spot. It had 15 spaces to the right to go to write it out the long way. If I move it back a space just to write it in scientific notation, that means it's got even further to go if I want to scoot it over to the right, doesn't it? Because I just put it back another space. So I'm going to have to add another space, and I'm going to have to move that decimal point to get it to where it needs to go if I wanted to write the number out in the long way. So I'd actually have to say 3.5 times 10 to the 16th after I multiplied it. I have to kind of fix the number a little bit to make sure it's in proper form. Just a note that if you have negative exponents, let's see if I can't just do this one quickly. 6, this is number 15, 6 times 10 cubed. 7 times 10, I believe that's to the negative 8 power if I'm kind of in a dark place. Yeah. Okay, so I can say 6 times 7 is 42. And then I've got 10 cubed times 10 to the negative 8. So I would say I would add the exponents. 3 plus negative 8 is negative 5. So that's 42 times 10 in the negative fifth. But remember, when I write it, I've got to have the decimal place here is not really right, is it? It has to be just one number to the left, so I've got to move it here. Now, let's think about this. If I had written it the way I've got it right here that I just underlined, it had to go 5 spaces to the left to be the correct number, okay? Well, I already moved it back another space, so it's already gone back to the left 1 space. So instead of negative 5, this would be 10 to the negative 4 because I've already scooted it to the left 1 more space, so it doesn't have so far to the left to go anymore. So it would be times 10 to the minus 4 in that case. I want to jump down to one like 29. Now let's do 27 first. Let's see if we can't fit more of these in here. 4 times 10 to the minus 3. And 2 times 10 to the minus 12. All right. Now, remember, we got some things going on here. We've got regular division. 4 divided by 2 is going to be 2. Now, I've also got these tens to divide out, and this is to the minus 3 on top and to the minus 12 on bottom. We can say just subtract the exponents, because remember, when we divide, the rule is we subtract them, negative or positive, it doesn't matter. So if I start on the top, I have negative 3 minus 12. That becomes negative 3 plus 12, which is just 9. So this becomes 2 times 10 to the 9th. That was kind of nice, wasn't it? Let's look at 29. It might not be so nice. We'll see. Okay, so 29 is 6 times 10 to the minus 8 over 5 times 10 to the positive 8. Okay, so now, if I had 6 divided by 5, I could write that as a number. Probably, actually, I am going to want to write that as, let's see, 5 goes into 6 one time. That's going to be actually 1.2. You can actually divide that out on your calculator if you have trouble with that. But again, that's something you were doing in elementary school, right? So times 10, and let's say I start at the top. It's minus 8 minus 8. So that's times 10 to the negative 16. So the answer is 1.2 times 10 to the negative 16. Remember, I'm just applying my rules of exponents. I'm subtracting the exponents. You could move that 10 to the negative 8 down into the denominator and have the times 10 to the 16th in the bottom, but then that's kind of a mess to deal with. Well, I guess let me see if you had done that. You would have had 1.2 over 10 to the negative 16th, right? Or 10 to the positive 16th. Because if you move this down to the bottom, you would have had 6 over 5 times 10 to the 8th, and then you would have moved this to the bottom times 10 to the 8th. It would have been 10 to the positive 16th on the bottom, but because we don't write that way in scientific notation, when I went to move this to the other side, he wouldn't like it. Remember, the exponents are like not happy if they're negative and happy if they're positive. I can force that on the top. The 10 might not be happy about it. It's going to be negative because it doesn't like moving to that other side. But that's how I could kind of look at doing that another way if you're thinking, well, let me move these things around. I would suggest to you that the more straightforward way is to just subtract them and put them on top. And that way you don't have to be moving stuff back and forth in these problems. They're just kind of a little different than some of the other things we've done.